What's up, everybody? Welcome back to 8th grade science. Today we are talking about two new terms, the term valence electron and then the terms reactive and stable. All right, we're going to connect the number of valence electrons that an atom has to how reactive it is or how stable it is. So we're going to be doing a little bit of counting, and we're going to have to make sure we understand a term called energy levels, and that's what we're going to go now. All right. So you should have a guided note sheet in front of you. Make sure that when I pause and tell you to work on the guided note sheet, you complete the question. There should be 4 questions for you today. Okay? Today we're talking about why some chemicals react when they're mixed with fire and gasoline, while others do not react. Fire this here, the number of valence electrons, and I'm going to put this in a box because this is going to be one of your answers, determines reactivity. Alright, so yeah, that should be in the upper left of your graphic organizer of your notes. Please take a moment here to pause the video and to write that down, that the number of valence electrons determines reactivity, okay? And to understand what a valence electron is, we have to first understand something called energy shells. So let's take a look here at these atoms. So in the lower left, I have a model of the atom neon. And what we're going to do here is we're going to understand how many valence electrons there are in neon and how many total electrons. So let's take a look. First thing we have to do is understand how many energy levels there are. You're going to see that I put a 1 and a 2 over the rings around neon. That just means there are 2 energy levels or 2 shells around neon, all right? I'm going to circle all the electrons in blue that are on the inner shell. So if you see right here that I have 2 blue electrons, because those are on that first ring, all right? Now to figure out how many valence electrons I have, and I'm going to color code this. I'm going to use, let's use pink. And write that pink is valence. Now I'm going to go out to my second energy shell. That's the outside shell. There's nothing outside of it. And I'm going to circle every valence electron. 1, 2, 3, 4, 5, 6, 7, and 8. All right, so neon has 8 valence electrons. And according to our key, all that means it is stable. These energy shells you're going to learn a little bit more about in the next lecture, but they can contain only up to 8 electrons, except for the first one, which is a special case. So we come to around the outside, we have 8 valence electrons. That means that this atom is stable. All right? So now, y'all, I want you to take a pause and answer that second question on the lower left. It asks you how many shells there are in neon. This should be very quick, very easy. We just labeled them in red. All right? Now, y'all, we're going to move over to the right side, and the next question in your guided notes asks, how can you determine if an element is reactive or stable based on the diagram? I want y'all to look at these notes and try and tell me, how do you know if an element is stable? It should have a special number of something. And how do you know if an element is reactive? It should have a special number of something as well. Go ahead and fill those in, y'all. All right? Now, hopefully, we have determined, if we are back from filling in that little blank, an element, y'all, is stable if it has 8 valence electrons, and an element is reactive if it has 1 or 7 valence electrons. So all we're practicing today is understanding what a valence electron is and counting them, okay? So let's do the exact same thing in the lower right. You're going to notice that we have one more example here about chlorine. Your guided notes are asking you how many valence electrons are in the chlorine model and what does that mean for reactivity. Well, first what I'm going to do is I'm going to use blue, or I'm going to use red to label how many shells we have. Right here in chlorine we have the first ring, we have a second ring, and we have a third ring, okay? So the only valence electrons, the only electrons I care about are the ones in the outer shell. So now let me go ahead and take my purple or my pink, circle the first electron, second in the outer shell, third, fourth, fifth, sixth, and 7th, y'all. So we have 7 valence electrons in this atom. And of course, we know that means, if we check our key up top, that we have a reactive element. All right, and I'll use red here. okay? So all that matters for these problems are figuring out which shell is on the outside. Just count from the inside out and get to that last shell, and then count all the electrons that are in that valence shell, okay? So what we talked over today, or how to find valence electrons. Valence electrons are the amount of electrons on the outer shell. The outer shell electrons determine how reactive an element is. If there's 8 valence electrons, the shell is full, and we call the atom stable. It won't change or react. If we have 1 or 7 valence electrons, we're very close to having 8. We either need to lose 1 or gain 1 to get to 8, and that makes the elements very reactive, all right? We're just going to practice a lot of counting today, but remember in your heads, y'all, 1 or 7 means reactive, 8 means stable. Great job, y'all.